Okay, let's take a look at example 4. Now remember, there's something called difference of squares, and I think this problem is trying to test you on difference of squares. Now, when I have, if I have a squared minus b squared, this is what we call difference of squared. I'm subtracting two squares. It becomes a plus b, a minus b. So, for instance, if I have, um, for instance, if I have 25a squared minus 9b squared. You see, since they are difference of squared, it is smart to create this to be a one common square. So I can say this is 5a all squared minus 3b all squared. And so this becomes 5a plus 3b times 5a minus 3b. So you always have to plan it that way so that it becomes difference of squares. So this becomes, a square, this becomes a square, perfect square, and then you can subtract them. So let's come back here. So for this particular problem, they gave us 4x squared minus 9. So we can express the 4x squared to be the same as 2x all squared. And obviously 9 is 3 squared. So we have 4x squared minus 9 squared becomes 2x all squared minus 3 squared, which means we're going to take the first one, which is 2x minus 3, and then 2x plus 3. So if we can express this like this, that means 2x minus 3 is equal to ps plus 2. So the p obviously is going to be our 2, right? And our t is going to be our 3 here, right? So the question is asking for the p, so obviously the p here is equal to 2. So you need to understand how to just convert this perfect square into this distributive structure so that you can always pick the one that satisfies the requirement. So here your p is equal to 2, all right, because it's coming from the 4x squared.